Hello everyone. In this short video we're going to talk about triple integrals and their applications. Why do we have to study triple integrals? One of the application of a triple integral was finding the volume of a solids. But maybe some of you have said volume of a solid could be found by a double integrals when you take the base area and multiply by the height. Therefore, and the height is a function of the region. Why do we have to study triple integrals? There are many physical applications such as mass. For the solid is a density, and the density, if it's not uniform, is density times the volume. And since on a 3-dimension, if the mass are not uniform, and it depends to which location you are at, therefore at any different location, your density is different, you have no other option to be able to use triple integrals, because in here you have to do it with respect to z and a y and an x, and you can also change this order because there are 3 of them. You can have 6 different ways this be written. Okay, let's talk about the volume, and then from volume we're gonna go ahead and take the volume and multiply by density, and we're gonna find the mass. This is nothing except a function of a multivariables, which x and y are independent and z is a dependent. And this does represent a function because for every unique order pair you have only one z value. This is not a function because for every unique order pair you're going to have 2 z value. What is the graph of this one? If your y become a constant, like 2, 3, 4, 5, -1, -2, therefore the graph of the solid is tracing the zx, is going to become a parabola. Same thing if your x become a constant, the trace in the zy become a constant. The trace in the zy become a parabola. I'm sorry. But if z become a constant, the trace in xy become a circle, which is a special kind of an ellipse. Therefore, if I want to graph that, if z becomes 0, you have a point. But if z become 1, then 2 times 1 is 2, and you're going to have a circle with a radius of square root of 2. At where? At z equal to 1. Therefore, at z equal to 1, you have a circle with a radius of square root of 2. At z equal to 2, 2 times 2 is 4, you are going to have a circle with a radius of 2. Get a little bit bigger, that's your y, that's your x, and that's your negative side of this, and that's become a little bit bigger. Then as I go on, this circle gets bigger and bigger and bigger, and I'm gonna have a paraboloid. Okay, but what is this? Because you have 2x-intercept, 2y-intercept, and 2z-intercept, and all these coefficients are the same, that is going to become a sphere with the radius of square root of 80, which is 16 times 5, 4 is square root of 5. If I assume that 5 is a 4 and the square root of 4 is 2, that's make it 8.
Therefore, I need a little bit more than 8. Therefore, I go 8 this way. I go 8 that way. Positive side of y, negative side of y, positive side of x, negative side of x, negative side of z, and the positive side of z. And in here, these are my x and y, and this one is the y and z. You know, I didn't do it perfect. Therefore, what I see right here, I see that at some point my sphere does not let for the parabolic, the cone, or that is a cone, is an elliptical cone, and I call it paraboloid, that's fine. And this one is gonna be a stop, and the cone doesn't go anywhere. Therefore, this pretty much is gonna become my graph. And I wanna know what is the volume of that solid. Then I know this one is gonna become my solid below, and this solid is gonna be above. Therefore, this is my lower z, this is my upper z. Therefore, if I want to find the volume, what I'm going to do, I'm going to take my solid and I'm going to divide it into infinitely many cubed. And I'm going to find the volume of one of these, and that's the delta z. And said the volume of a representative is delta x, delta y, and delta z. And I'm going to sum up all of them, and that become dv. And this become your region. And you know, some books they call this one a Q, some books they call it S, but this represent, I'm sorry, this represent not a region, it represents a solid. If it's a region, then you need 2. Therefore, this one is going to be triple integral. But in here, I have to determine which one I'm going to make, which order I'm going to write these. Well, I already know my below is going to become your z, which is negative plus 1/2 x squared plus y squared. My above, I need the top portion of the sphere. I need to make it as a function. Therefore, when I solve for z, I have to take this one and solve for z, and my z is a plus minus a square root of 80 minus x squared minus y squared. But I don't need the negative because I'm talking about the above portion. Therefore, this would become 80 minus x squared minus y squared. But I'm going back to my region now. This is my region. What is a region? You got to look this graph from the top, the solid you're trying to find the volume of it, and see what is the projection of it on the xy plane. Whatever the projection is, it could be a rectangle, it could be a square, it could be a circle, it could be a parabola. Whatever it is going to determine your region. Okay, therefore I know these are pretty much like an ellipse. If I go right here and draw me an ellipse, from the top, that ellipse is going to cover everything, and my region is going to be nothing except that. But what is the radius of it? Whatever the radius of it is going to be from z-axis to the point of intersection. What is the point of intersection? Point of intersection is where both the z from a cone and z from a sphere have exactly same value. Okay, then in here I go there and I said if I cross multiply that cone, it becomes 2z equal to x squared plus y squared. That's my cone. And the other one is x squared plus y squared plus z squared equal to 80. I either have to bring the x squared plus y squared and plug it in here and solve for my region, because that time my z is going to be eliminated, or maybe I'll find the easier way. Maybe I'll go back and replace the x squared y squared by 2z. That's good. Then I'm going to find my z. If I find my z, then I got my region. If I find my z, I got my region. And both regions have to be exactly the same. Then in here, I'm going to put z squared plus 2z minus 80 equal to 0. And if I factor that, that becomes z plus 10 and z minus 8. And your z is negative 10. I don't need that because that's below my solid. And z is equal to 8. Okay, let me check if that satisfies both of them. 2 times 8 is 16. And if I put 8 right here, that becomes 64. 64 go to other side, it becomes a negative. And it becomes 80 minus 64. Oh, that becomes 16. That's good. Therefore, my region is nothing except a circle with a radius of 4. 4 here, 4 here, 4 here, 4 here. That's my region. I got my region. In here, I can make my x, right here, I can make my x fixed by making my y 0. Therefore, your x go from a negative 4 to 4. But because I made my x fixed, my y must varies. And what is my y? My y is plus minus square root of 16 minus x squared. Perfect. And I'm going to consider the whole circle. This becomes negative square root of 16 minus x squared. And this becomes 16 minus x squared. Then the first one is a z, the second one is a y, the third one is an x. This is the volume of the solid. You know, I want you to know one thing. In here, I see a lot of x squared plus y squared, and I see a circular region. Maybe in here, in order to solve it, a polar coordinate helped me a little bit. But let me go ahead and take, because polar coordinate is always correspond to these two. Okay? Then, from today, you have to realize one thing. There are certain solid that the length, the width, and the height really didn't do a good job. I'm going to do it this way. The length and the width and the height are all three of them are a straight line. Therefore, here your x is straight, here your y is straight, here your y is straight, and your z is straight. That's why whenever you're trying to find the order triple, you're going to use x, y, and a z, and you're going to get to that location very easily. 2, 5, and 7. You see, that's exactly become a straight line. Therefore, if this is 2, all this is going to be 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 2, and all of this has to be also a 5. And all of them have to have same z. Therefore, you see that graph at that point is a corner of a box. But there are certain solid are not all three quantities are straight. Maybe the bottom is a circle. And if the bottom is going to be a circle, therefore, there is no way I can use this one as an x and a y. I have to use this one as a polar coordinate.
And since I'm using this one as a polar coordinate, instead of x and a y, I have to use r and a theta. Therefore, I'm going to use for this one not x and a y because I am going around the circle. Instead of a x and a y, it's a lot easier to use r and a theta. But someone said, what happens if this becomes 3-dimension and the bottom become round, but the height becomes straight? Or sometimes the side become round and the y becomes straight. And sometimes your x becomes straight, but this become nothing except a y squared plus z squared, but your x becomes straight. Or in here, you have a circle here, and that become x squared plus z squared equal to r squared, but your y is straight. Or in here, you're going to have x squared plus y squared equal to r squared, but your z is straight. In this condition, I cannot use x, y, and a z. I use r, theta, and a z. Maybe r, theta, and an x. Maybe r, theta, and a y. These are the triple called cylindrical coordinate, not a Cartesian. Therefore, in the next chapter, we talk about cylindrical coordinate. Therefore, in here, because I see a round here, maybe I can use cylindrical coordinate means my z is straight, but my x and a y, I can call it to r and a theta. Okay, what does it mean? Means I take my region. My region was x squared plus y squared equal to 16. You know my region can be divided into a sector. Therefore, in here, I'm going to say my r is always 4. And the theta I require is from 0 to 2 pi. Therefore, instead of writing from -4 to 4, I use theta. And instead of a dx, I put d theta. Instead of a dy, I'm not going to use this number to that number. I'm going to use 0 to 4. And that's become not a dy, I got to put a dr. But you know when you change it from a dy dx to dr d theta, you will resurrect a factor called r. What I have is your z. Okay, I'm talking about dz. What is your dz? Dz has to be a function of the last two. What is x squared plus y squared? That's r squared. And what is the square root of 80 minus, if I factor a negative, it becomes 80 minus x squared plus y squared. That's the r squared. Therefore, I'm not going to use the triple integral using Cartesian. I'm going to use cylindrical coordinate. Therefore, my z is from 1/2 r squared to a square root of 80 minus r squared. And this becomes so simple because that's all I'm going to do. Then I have to do the next one. Next one, you have a r multiplied by both of these and do it with respect to r. Therefore, I have a square root of 80 minus r squared times r dr, and it go from 0 to 4. Because my region was x squared plus y squared equal to 16. And I have to do the other part. I have minus 1/2. I have a r squared. I have to multiply by r because that's the negative. I wrote it as a sum at the difference of two integral. I have r squared and I have a r. I have a dr. This r is your factor. I have to multiply by both of them from 0 to 4. This is not hard to do. That's r cubed. That's r to the power of 4 over 4 from 0 to 4. And 4 to the power of 4 is 16 times 16, which is 256 over a 4. But I have to multiply by 1/2 and make this one an 8. And that's my negative.
In here, I have to use this one as a u. When I make this one as a u, I need a negative 2r here. I multiply by negative 2, and I divide it by negative 2, and that becomes negative 1/2 integral of u to the power of 1/2 du. And the answer to that one is going to become, okay, right now this answer to this become negative 1/2 u to the power of 3/2 times 2/3, and that's become 2/6. And what is your u? Your u is 80 minus r squared. Then here it becomes negative 1/3 of 80 minus r squared to the power of 3/2 from 0 to 4. Okay, then what is that answer? When I put 4 in here, I get 16. 80 minus 16 is 64. 64 square root of 64 is 8. That becomes 8 cubed. When I put 0 here, it becomes 80, but I gotta subtract. It becomes 80 to the power of 3/2. Don't forget, I have a negative 1/3 in here, and I have negative 256/8 in here. All I know, all of this is constant, and I'm hoping that become a positive number, because when I apply this negative, it becomes 1/3 of 80 to the power of 3/2, but you know square root of 80 is 9, and 9 cubed is way bigger than 8 cubed. Minus 8 cubed minus, and really 256/8, I can reduce it by 3 times 8 is 24, 16 times 8 is 2, that's become a 32, a negative 32. That answer is going to be a positive number. But this is, I did not do my theta yet. I have to do the last part, which is your theta. Your theta was from 0 to 2 pi, and d theta, don't forget I have that number in front of it right here, and that's become theta from 0 to 2 pi equal to 2 pi. Then the volume is 1/3 80 to the power of 3/2 minus 1/3 minus a 32. All of these multiplied by 2 pi. And I'm sure you can put this in a graphing calculator and you can solve that problem. But the issue, the application of it is, sometimes I go to that same problem and I'm gonna say, you know the other problem? That's my solid. And that solid, I want you to find the mass of it. Mass. Then what is the mass? Mass is rho times the volume. But I'm gonna say the density of this is not the same. At every different point, you're gonna have a different density. Therefore, your density is gonna be a function of x, y, and a z. Therefore, here, what I'm gonna do, I'm gonna just make it up, and I'm gonna say my rho is x, y, z is x squared plus y squared. I just made it up. Then I'm gonna say, what is the mass? Mass is gonna be exactly that problem, not any different, except the mass is gonna be density times the volume. Still, you're gonna have from 0 to 2 pi, you're gonna have from 0 to 4, you're gonna have from 1/2 r squared to 80 minus r squared. Still you have dz, still you have r, dr, d theta, but that gives you the volume. But volume times density, which is x squared plus y squared, that gives you the mass. That's the application. And if you want to do that, that's another r squared, and that may come in the r cubed. Therefore, is not much different. You do the same procedure. But sometimes you talking about moment. We talk about the moment. We have a linear moment, and the linear moment it is sometimes you're trying to sack somebody, you're trying to attack somebody, but you are not big enough. You come back a few steps and run toward him. Therefore, moment is always force times distance. In this case, I'm going to make my force to become nothing except your mass times the distance. Then, if I want to find the center of the mass, and to make my fulcrum balance, you have a mass here, you have a mass here, but there is a distance here and here. Maybe maybe these masses, one is 200 pounds, this one is 50 pounds. The fulcrum in the middle does not do any good. I bet you I have to increase his moment by moving the fulcrum here. Therefore, the big number by a small distance is the same as the smaller number by a big distance. Therefore, mass times distance, the sum of it, maybe there are 5 or 6 of them, should be the same as sum of the masses times where the fulcrum is going to be moved. That's going to be the average. And if I solve for x bar, it's going to be the sum of mxi over the sum of the masses. And you can have I from 1 to n. Same thing for that one. The top call a moment, and the bottom call the mass. Okay, remember, if you are in a 2-dimension and you are here, you can have moment respect to x, you can have moment respect to y. Why you can have 2 of them? In here you had only 1 x bar. Here 1 x bar, but in here is a plane, you need x and a y. Therefore, your x bar is that distance. Therefore, if this is the center of the mass, that distance called moment, this one called moment about the y. But it still is a mass times distance, but your distance still is x over the sum of the masses. But somebody said, what is your y bar? Your y bar is your moment about the x. Therefore, your y bar is moment about the x over the sum of the masses. But still you have to take your mass multiplied by that distance. And that's the direct distance from the x, and they call it a y. But somebody said, no, I have a solid, and in here I need x bar, I need y bar, and I need a z bar. Please pay attention. When you have x, y, and z axis, and somebody said, what is your x? You're going to say, you know what? If this one going to stop, your x, this is your x axis, is coming out of the board. X is this axis. When I come 1, 2, 3, I'm getting away from the y, z plane. My y is here. When I get away from, I make my y increases, I'm getting away from that plane, which is the z and x plane. When I go over the z and change my z, I'm getting away from x and a z plane. Therefore, the moment, the x bar is going to be moment about the y and a z over sum of the masses. What is the mass? Mass is rho times the volume. Then you need that triple integral. And what is the moment? Moment is the mass times distance. Oh, what is the distance away from yz? Is x. Therefore, if somebody said, what is the formula for x bar? You have to say you have a triple integral, dv, that's your volume. You got to multiply by rho xyz, that become a mass. If you do the x bar, you have to multiply by x all over. Here is a mass, is only density times the volume. The difference between them is an x. But what is the y bar? Y bar is a distance from x and z plane. Therefore, the distance from xz is a y. You need a triple integral. That's the volume. That's your density. And I need a distance. That distance is a y. And that is your q. But on the bottom is gonna be the same, no different. Somebody said, what is the z bar? The z bar is going to become moment about the x and a y over the sum of the masses. But what is the moment about the x and y? If this is x, this is y, the z is going to be your distance. Therefore, your moment is density times volume times distance over rho times the volume. What is the volume? It's a triple integral over the solid dv. What is your rho? Rho is maybe not going to be uniform. That's your rho. But what is the distance from xy? That distance called a z. Over same thing you had over here, that's become your mass. Therefore, one of the application is your x bar, y bar, and a z bar. And I'm going to have a brief touch on something else. Somebody said, I want to throw a slingshot. How am I going to throw a slingshot? I'm going to take this slingshot, I'm going to rotate and rotate and rotate and rotate and rotate and let it go. I am increasing by my moment right here, but not by running in the straight distance, but rotating. This is called the second moment. And this is called the moment of rotation. And the moment of rotation called inertia. If you remember from physics, a kinetic energy for linear distance is 1/2 mv squared. And if you are rotating around the circle, your arc length is always r times theta. How can I change this one to a velocity? If I divided both sides by t, s over t is a linear velocity, omega over t is an angular velocity. If I come and place that v by r squared omega squared, that's called the kinetic energy in rotation. And that kinetic energy is 1/2 m r squared omega squared. This mr squared is exactly what you do right here, because this is the radius of your rotation. That is the radius of your gyration. Therefore, this is called moment of inertia. The difference between this and the moment was mass times distance. Moment of inertia is mass times the square, but the distance must be a radius. Therefore, what is the moment of inertia for Ix? Oh, that's not hard. It's m r squared. What is the mass? Rho times v times r squared. But I want you to please pay attention. If this is your y and this is your z, this is your x, that must be a radius. Radius means this. And how much is that distance? That distance is, this is your y, this is your z, that distance x is a square root of z squared plus y squared. But I need x squared because I'm looking for r squared. Oh, that r squared is z squared plus y squared. Therefore, rho v, the distance is z squared plus y squared. Goodness. But if somebody said, what is the moment of inertia about the x-axis, you better say it's a triple integral. My density, x, y, z, times the volume, that's your math. But if I multiply by distance, if the distance is x, that's called a linear moment. But if the distance is r squared, which is z squared plus y squared, it will call the moment of inertia. But what is the I respect to the y? Same thing. You have to solve for that. This become x, this become y, this become your y-axis. And that become the volume of a solid, density, but the distance is going to become x squared plus z squared dv. And what is the moment of inertia about the z? Mass r squared. Your mass is density times the volume, but the distance is, right now this becomes z, this becomes y, and this becomes x. And that becomes x squared plus y squared. These are called the moment of inertia. I want you to understand one thing, and that is very important. In physics and engineering, the moment of inertia of a mass, the moment of inertia of a mass, that's the moment of inertia of a mass, is used to find the time required for a mass to reach a certain angular velocity around a certain axis. The greater the moment of inertia, the more force must be applied to reach the given speed. That's very important. That's why we have so much issue regarding centrifuge and enriching uranium, because you know the moment of inertia is very important on those things. But please pay attention. What do you have right here? In here I can write the IZ as, break it down to two triple integral of rho xyz x squared dv plus another one is a q rho x y and a z y squared dv. Oh, x squared is the moment of inertia from a plane, and that plane is y and a z. This is the moment of inertia about a plane, because remember you eliminate one of the variable, and that's the x and a z. Therefore the I of a z can also be done by I, the moment of inertia about the plane, this is the y and a z, plus I and a x and a z. And if I want to do this one right here, I can write this one ix as z, which is ix and a y, and y is x and a z. And if for this one, I can do iy equal to I, this is x squared, therefore that becomes y and a z, and this is z squared, that's become x and a y. Therefore, if you want to do each of these single, x squared, y squared, z squared, perfectly fine. You can use this formula to find the moment of inertia. That's extremely helpful because these processes are not easy. Another thing, this is the last one. I hate to leave it off. Moment of inertia is mr squared. This is a radius. If I solve for radius, radius cannot be a positive. This is called I over m. This is called the radius of gyration. If you put x in here, that's a radius of gyration about the x-axis. If you put y in here, that's a radius of gyration about the y. And if you put z right here, is a radius of gyration about the z. Also, another thing you need to know, I think I did everything. everything is good. This video took too long. Thank you, and I hope you enjoy some of the application of the triple integral. Thank you.